It's an interesting topic in terms of geospace, means of observing the surface of the Earth. I suggest that we first listen to 3 presentations of companies doing private spacecraft, geoinformatics, and Rostelecom. And then we will discuss the issues arising around the possible solutions. Now I give the floor to Nikolai Videnkin. Hello, dear colleagues. I would like to show you a presentation to explain what the market of small spacecraft is about and what the current market trends are. Next slide, please. If we talk about small spacecraft are spacecraft of up to 100 kilograms. If spacecraft are called weigh 10 kilograms, then it's nano spacecraft, and if it's a spacecraft of 1 kilogram, then these are a particular kind or class of special nano systems. Please look at this graph. We can see that there is a trend of launching nano spacecraft. In the West, this trend has been developing much more quickly than in Russia, but in Russia we also have some increase in the launch of spacecraft because universities and private companies are already entering this market. If we look at this graph, we can see that most of the Western market is taken up by spacecraft of up to 10 kilograms. And in Russia we have micro spacecraft and nano spacecraft have a smaller part of this market. If we look at the use of this spacecraft in the communications industry or for scientific purposes, we can see that spacecraft of this class are hardly used, and nano spacecraft are already beginning to see their use in the communications industry, and we use the micro spacecraft in their communications industry because right now technology has made it possible to use more powerful sensors for such spacecraft, more powerful transmitters. Of course, we launch a large number of minor spacecraft, but still it's just a minor share of such spacecraft in Russia. We also use nano spacecraft for Earth remote sensing. And we are planning to launch spacecraft weighing up to 11 kilograms. And here we can see that some of the spacecraft can see a decrease in their size. Why did this become possible? This is, of course, about the possibility to use some systems which before it was impossible to use. For example, the engine used to weigh about 100 kilograms and about 500 kilograms were necessary to keep a spacecraft in the orbit. Right now, it's possible to have a device of 2 to 3 kilograms to launch such spacecraft. Furthermore, we can now minimize the number of Earth stations, and some new technologies are available to send signals from one spacecraft to another one. Constellations of spacecraft can be created, and the GPS group is one example of this progress. because right now communications between spacecraft can be maintained for half a year without any influence from people. Furthermore, there is certain production standardization. And of course, the CubeSat technology is one example here, because you can copy such spacecraft. You can make 100 or 20 or 6 spacecraft, and this manufacturing standardization results in the growing demand on this market, and it's becoming cheaper. Now universities and private companies can also launch such spacecraft. And furthermore, there are new services, new technologies. We can now see many more spacecraft in the orbit. We can have absolutely new markets opening up for ERS and for other sectors. Another big advantage is that small spacecraft can just be put into orbit. Well, I can say just, it's not a simple process, but nevertheless, we can use small spacecraft just almost anywhere. Even astronauts can launch them, as well as various deployers or launch units that can launch such systems. And of course, this results in more possibilities to use nanosystems in space. What's going on the global market? It's not very recent data, but let's look at the Labs Center. Planet Labs. I'll try this mic. Planet Labs is an organization which has started copying or mass producing Triumph spacecraft. There is a camera inside, and they say that this camera is going to cover the entire planet Earth. They started launching such spacecraft in a huge amount. This works. Investors are interested. These spacecraft work in the orbit. Of course, they don't live for dozens of years like other ERS, but nevertheless, users are interested. There are also other players on the market, such as Skybox. No one believed that this spacecraft was going to work. This spacecraft has a weight of less than 100 kilograms, and the resolution is 1 meter. It can have videos and take videos. Right now, this is one of the most promising companies on this market, which confirms that they are really going to launch a large number of spacecraft to video the Earth. Now we can have Facebook. Facebook is also going to launch a group of spacecraft for communications purposes. They are planning to launch a huge number of small spacecrafts to ensure the internet and telecommunications in relatively unpopulated areas. And they are also going to launch unpiloted vehicles to ensure internet over different points of Earth. Google is also planning to launch its own telecommunications network for disseminating internet worldwide. They have already launched some satellites in the equatorial part of the Earth, and they are also planning to launch their own group to film the Earth's surface. Furthermore, the forecast of market development for small spacecraft is quite positive. This market keeps growing, and not only in the Earth, in Europe, but also in Russia. We can see this trend clearly. The areas which have a potential, it's communications and Earth remote sensing, ERS. These are the most promising areas. That's it. Thank you very much. Thank you, Nikolai. That is very interesting. I think there are a lot of questions, but they can be discussed later. Now, I would like to give the floor to Mikhail Bolsunovsky. You are going to tell us about the informatics trend, as far as I know. My presentation is dedicated not only to spacecraft for Earth remote sensing, and we actually specialize in this area. Can you hear me? We specialize in space, Earth remote sensing, and remote technologies. My presentation is a bit broader than that of the previous speaker, but this is good. This is a certain bridge towards the next presentation from Rostelecom, who are very active in geoinformatics. Now I have to deal with this. This is a very simple scheme of what we are working with. We deal with initial data. This is space filming. Many of us are already aware of this. There are tools to get this initial data, to work with it, to archive it. There are processing technologies, access technologies, and the distribution of the results. And there are also geoinformatics systems which help us work with this data for a large number of end users. Now I'd like to go through each of this block. As for the initial collection of data, I'll speak very briefly. There are different approaches here. There are different contact or surface tools of receiving this data, or remote data collection. There is aviation filming, which is also a source of data, and traditionally both space filming and aviation filming have been competing. Furthermore, there are distant means of getting this data. There is radar filming, laser filming, spectral filming, and so on. So the main trend we can currently see is that this gap between aviation and space filming are being bridged. We can bring together those two seemingly incompatible things. And as a result, we have huge databases because there is a large number of vehicles which are put into orbit. We need to do something with this. We don't just need satellites or filming as a goal in itself. The company Airspace was bought by Google, as everyone is aware of, and this is a certain kind of an intermediary link which makes it possible to film the Earth very precisely with a very high aviation-type resolution, but not over a very brief period of time, but for a much longer period, because there are some satellites which can be in space for a period of several years. There is, of course, the space filming by groups of satellites, up to 24 space vehicles. And even the old market players who occupy a lion's share of the market, such as Airbus and others, also build their own groups consisting of different satellites But the objective is to make this filming more effective, to get more initial data. And instead of filming the same facilities, they redistribute the tasks between the satellites. And everyone, including Airglobe and Airbus and ourselves, we also do satellites, and we are also facing this challenge. We want to get certain kinds of sets of data, and the key here is process data, because the customers, the end users, are not interested in unprocessed data. They are interested in the result. So this service is provided as a part of technological complexes which are ready to be built into the infrastructure of the customers. And here we are moving on to the next stage, the implementation of technologies for processing initial data. The main trend is getting databases and data sets which include a lot of data. Once again, these are blocks of data. There is a cloud processing technology, and we get content instead of images. Big data is something which our colleagues from Rostelecom do. And in fact, they are not original here. This trend can be seen very clearly throughout the world. Almost all telecommunications companies are shifting towards processing and storage of data. So the data we are talking about, space images, are of course big data. Earlier, when there was just one satellite or two or three satellites in the orbit, it was different. But now there are dozens and even hundreds of satellites in the orbit. There are certain approaches to processing big data, involving the speed of processing and so on.
The next thing here, big data is okay, it's good, but it's also referring to availability of technologies, comfortable technologies, both for initial data and the processing results. So these are the cloud technologies. As you may know, Rostelecom is responsible in this country for cloud computing, to a certain extent a whole number of other technological solutions. Good prospects for cooperation and building some infrastructure of world class. So there's no ready multi-platform complex solution for the big data. So nothing has been established so far. So Rostelecom, as I know, is following this way. So our colleagues will share that with us. Okay, as a cloud service, you can have different options for operation. You can process in cloud, you can store in cloud, you can redistribute, you can do the hosting in the cloud. So there are vast opportunities. As far as some other directions, is it complex in the different data and content instead of images? Again, this is a result of the trends I have mentioned. The complexing of the data is that the emergence of new technologies or automation of older technologies leads to the emergence of formats and platforms for their complexing with other similar data and content instead of images. Now talking about not data can be converted into information. We're not talking about converting into mass information. So they're talking about content. But even on your cell phones, on your smartphones, you can get online data, prompt data, and simplified data ready to be used. So this is what they call content. As for the tools, there are two main vectors: a great increase in the volume of the data, then aggregation of the data from different sources. And now I want to talk about geo-informational systems. Again, we see the massive character, crowdsourcing, mobile devices, social media, unmanned aircraft, and 3D geo-informational systems. Now we live in an interesting time because of some projects like Google Earth, Google Maps, Yandex, and others. The Airspace Imaging. They are now in the day-to-day life. It's good on the one hand. On the other hand, this market used to be a privileged market. There were very specific people, the experts. I was talking about accuracy and and there was a very special lingo for those guys. Now people don't talk about that, but they use it in their day-to-day life. They're ready to consume that in a massive order. So all of us are already consumers of these data. And then there's a reverse progress. It's that when people prepare to consume the data, are prepared to participate in the creating of this. You know, the street maps experience. You also know the Moscow government projects. So some elementary things. You can all use 3 buttons on your device, and everybody can contribute to the portal, add some images, pictures, comments. Another good example is when all of us, all over the world, were looking for the missing Boeing, whether they should be in the Pacific or in the Indian Ocean. So a lot of people actually were involved and were contributing. Over 100,000 people. They were studying the images and trying to find and define whether it's the wreckage of the airplane or something else. So everything is getting to be mobile. GIS is getting to be mobile. And then KISS is becoming to be an actively player in the social media. We mentioned Facebook. So all of the friends who specialize in this area, they're all very actively looking into space data and the geoinformational technologies. Where you should be finding your friend or locations over somebody's mobile phone. They're all elements of the geoinformation technologies or geomarketing. And this is naturally being combined with the data that we described in the beginning, the airspace imaging, unmanned aircraft. I said everybody has one in his pocket. No, not yet. But it will come. It will come sometime in the future. You will have it in your pocket. You can see it in so many exhibits here, which could be another source of information, very prompt. Could be online. So data submission in 3D, this is not enough already, talking about 3D geoinformational systems. So in order for you to come into the building, you'll have the complete picture, a virtual reality, complete information on all the components of this virtual world. We're now in the room, and you can have an ideal image. If this is a virtual room, we could have get the information why this particular mic is not so good. So this is a very general picture of what we have today. So the main conclusion, the approaches that seem to be correct a year, 2, 3 years ago, they don't apply anymore. And there are world trends. We're now at this Open Innovations Forum. Everything is in Chinese. In 2, 3 years, believe me, these trends will be fully in force. If you are out of the trend, then you are not in. So I may be calling upon you. Please think it over. So look at it from the viewpoint of the existing trends, tendencies. Think ahead. Look ahead. All of us in his own business. Thank you so much. Thank you, Mikhail. The floor goes to Robert Paulus with his presentation on the common data space for Rostelecom. Thank you, Maxim. Okay, colleagues. Mikhail has given a a certain preview to my presentation, and he's told you a lot about it, so I'll be very concise. Few words on the market. As it is now, the geodata is becoming mass content, and is being used wider and wider in all the industries. So if you look at the industry solutions, the geodata is used to be monitored for agricultural land, for forests, for forests being cut, for forest fires, for environmental status, both for what's happening and actually for for invoicing, let's say cloud moving this way or the other way. You can also monitor what's happening with the road construction. You can model the situations. You can model and forecast the road impact on the landscape, whether you should remove a hill or not. Or when you plan a city layout, whether you should put your stadium here, or maybe you move it aside a little bit. You can use a data system instead of doing it live. You build it and then you have to tear it down and rebuild it. So when you use it widely, there's a certain problem, and it has to do with the size of the data and their popularity. So what's happening is, because the size is very big and the systems are very complex, a solution is normally offered that is resolving only one job, and then you make a neighboring system to do something similar. So there's a vast amount of some regional systems for one region only, and that is a system for one particular job, in fact. And then everybody's trying to integrate them in between, and then suddenly it's very hard, and you have to make a system to integrate the other systems, and this seems like a vicious circle. So what we are missing is a standard system of the coordinates. There's a Western system, there are regional systems of coordinates, and everything is in this system. What is missing is universal tools. And currently, what is new is that all of the systems are imported, and they were now dependent on import. A year ago, that was okay. Now, this is suddenly a problem. So all of this is happening like, like a snowball growing. So understanding emerged. There should be one single common space of geodata, which will be a system capable of collecting and integrating all of the geodata and building a system, a mechanism of processing all of that, and then to build a superstructure, the tools for using of that for different industries. It is understood the system should be a multi-level one. So there should be a federal level, a regional level, and municipal level. So the consumers, the clients, would be both federal authorities, major companies, federal level companies, and then the regional authorities and regional companies, as well as municipalities and smaller businesses covering a town or a neighborhood. A system like that, with its complexity, it is easy to say why Rostelecom is moving that way. There are not so many companies in Russia capable and having the capacity to store and process these data, to transfer this data, and having enough trained personnel and expertise that could be easily scaled up to process all of this data. So Rostelecom being such a company, and we believe we are best suited to implement such a project. When I talk about the common platform for geodata, we talk about an information system, a solution. If you look at the complete ecosystem, that includes satellites, receiver stations. So in general, we'll start thinking about a complete ecosystem. So it's not incidental that we have here our colleagues, and we're talking to them about that. As we look at the product portfolio, there's a bank of geodata being built. There's 3D models of the landscape, and then there are some industrial solutions for topics: theme parks, monitoring, modeling. And if you look at the roles played in this ecosystem, then you see that the complete infrastructure is actually will be done by us, by our company. Maybe not all of the solutions. Yeah, there's too many of them, because we'll involve our partners in that. Some industrial solutions will be offered by our partners. But we're creating a new market, and there's enough space in that market for the partners. And then we'll see some customization for the specific customers. Again, we will mostly involve partners, and that will be yet another level of the market, and we're inviting all of the players to participate. And then the client, in this case, will be using our tools built by us, to resolve their jobs. They can analyze, model, monitor, compare with reference figures, and they take their own managerial decisions. And this is the basic idea of this presentation. Our company and our partners were prepared to create all of these tools so that the customers want to invent anything from the scratch, so that they can focus on their own jobs and targets. Thank you. Well, colleagues, we have reviewed all of the technological chain from the data source to the practical implementation of the common single information space where any of the consumers could operate and get the necessary services. But again, let me come back to the beginning of this conversation, the first presentation from Toria Aerospace. First, we will congratulate them. They actually made a breakthrough this summer in our Russian segment of the space research. The first private satellites ever have been launched by these guys. And they took quite some time, but Roscosmos, the state agency, actually they took it longer. So they make it in a very qualified way. So the satellites were launched. Private capitals were involved, so they could be proud of that. Let's hear their experiences and what are their prospects, please. Thank you for your congratulations. In fact, that was a great event for us. Toria Aerospace was founded in the year 11, so we're quite young in this industry. But my point, and I will back it up, the first challenge we faced in the year 11, and we're sharing our ideas, and we're actually investing our own money originally. So the first barrier, everybody was telling us, space is not a place for private initiative or enterprise. So this, they tell us, is an industry where only governments can operate. So entrepreneurs have nothing to do there because there's too much bureaucracy, red tape, barriers, high risks. So the investments are too risky. So in the past 3 years, so many events happened on the market. So that today you don't have to convince anybody that this is a very promising investment. That's interesting business for all the participants. Well, this refers to Russia to a lesser extent when it comes to making spacecraft, because this is still more or less a competence of the state. But worldwide, the Planet Labs, Skybox, other similar companies, when we were beginning, Skybox was a company they laughed at. The professionals laughing at, oh, well, it's never going to work. Planet Labs are our neighbors. We have 3 offices in Moscow in the Silicon Valley, in Munich. We're also neighbors to Planet Lab. We know this company very well, the guys. So people were laughing at them originally when they were voicing their ideas. Like, let's put in this little box a camera, and they told us they will have a resolution of 6 meters. And their plans now is setting up a group of 500 craft with a life of 6 to 8 months or so. So they have involved $60 million already, and they're developing. And Skybox, Nikolai forgot that, after they launched their craft a year ago, it's been working for a year. So their next launches, they will actually deploy the complete group. So this May, they were purchased by Google, so they're not a standalone company. And Google bought it for $500 million, which was a big event in our market. So geoinformation, geodata. We know space is already commercialized, have been commercialized for a while. Everything has to do with telecommunications. There's great amounts of money. But geodata used to be a state initiative for a long while. And we've been witnessing this industry developing very fast. When the data for lender imaging, the monitoring products, have become available, affordable to ordinary users, consumers. So we're witnessing that. So in the very near future, the groups of satellites that we're creating, our customers are not state-owned. The Perseus satellite, the first 4 craft to be launched next year, 3 of those will be monitoring ships in the oceans. So the first customer will be a shipping company, a non-government company. So the main market, 22 meters resolution, not a very good resolution, but very wide band of coverage, very big images. We're allowed to monitor agriculture. And this group of satellites we developed together with Deimos. We're actually developing their expertise with the Deimos one. We'll sign an agreement very soon, next week, so that Deimos will actually be fully prepared to take all of the data from the first 4 units. The interest is mostly from private American companies, mostly from agriculture. So geodata has become a commercially viable industry, and we believe in that. We put our stakes at that. We involve investors. There's business ideas around here, and I think we'll be witnessing a very interesting process in the very near future. So you could see the support of the government. Do you need any support from the government? Is a private support enough? No, you can't do without the government here. And Nikolai forgot to mention that the main barrier and the reason for actual breakthrough for the smaller craft is that the launches have become available without military conversion programs in the last 10-15 years. SSTL company grew on this because of this military conversion program. For smaller craft, they have become available. So some solutions could have been tested. So today, all of the smaller craft, they are launched as a side-by-side load.
So our DX, which flew in June, was like the meteorological satellite Meteor, a Russian-based one. It was supported by Roscosmos. This is the first PPP, and we launched it free of charge. This satellite was launched as a one-off program, and access to a satellite is the bottleneck for the entire market today. We are not requesting any special prices or special conditions, but we have some mechanisms in place. But what is more important for us is to book some space on a satellite. And we are a Russian company, so we have some preferences here. So what's your number in the queue? I hope, well, I think it's not number 1. There's another important issue. This concerns the equipment, the microelectronics base. Can you share your ideas about it? Is it possible to create small spacecraft on fully Russian components? That's an interesting question. We were criticized for DX, particularly the engineers working for Roscosmos, saying that we had an integrator's task and most of the components in DX are not Russian, are not produced in Russia. I think Nikolai could add a few details here, but our idea or our mission is not developing Russian microelectronics to a level when we can domestic solutions in small spacecraft. Of course, we use everything that is being created. For example, the small engines where there are virtually no competitors. But right now we are working not on Russian components for most part. Unfortunately, the Russian element base does not make it possible to create spacecraft with a mass of less than 100 kilograms. And these are not nanosatellites. These are small satellites. But there are some good examples. The Tomsk companies are trying to commercialize their research. But another challenge is that our manufacturers are not used to working with private companies. They just cannot build certain equipment with certain characteristics. They say, well, can you order some research and we will do research for you? But this is not the way you work with commercial companies. Some of our producers just cannot do this, and they do not know how to communicate with commercial partners. We have many different companies who have products that could be of interest to private companies. So if they overcome this trend, there will probably be some progress on the Russian market. But for the time being, we are forced to use foreign components. One thing to add: a few weeks ago, at the end of September, we signed an agreement with the Skolkovo Foundation, who are actively supporting the initiative of open innovations, and we received a grant of 250 million rubles. We are also invested 169 million rubles on our own, and we have an order to produce a spacecraft which is 1.5 meters long. Actually, it's a competitor of Skybox. We've been doing the research for a long time, and the first stereotype will be supported by Skolkovo. So as part of this project, as part of this grant, both the camera and the transmitter will be created in Russia, and all IP, all the intellectual property will belong to Russian companies. And this is some ground for joy. We are continuing this discussion, and I have a question which is as follows. Is the informatics industry ready for the introduction of Russian software? We understand that this is an open source, but still, can you answer it? Are you speaking about software or about remote sensing data? Both. Actually, this is a very important issue at the moment. Everyone is thinking about it. But for the end user, for the consumer, the most important thing is that a product should have certain properties for a small amount of money, if possible, and if there are some additional advantages, that's even better. So they want to see some additional benefits, such as greater functionality or productivity, and so on. From this point of view, remote sensing data is a very special product. As for remote special data, of course, the user is ready to use just any data with certain features. This is data which has certain properties, such as the possibility of stereo imaging, the number and width of channels. So there's a certain number of requirements. As for software, there is a similar situation here. Most importantly, this software should comply with the user's expectations. And here we have an issue. There is a certain cycle for developing this software. There are some options for raising investors' money, and we need time and efforts to commercialize this product. It's all very clear. Actually, there are some Western products which are now being used, and of course they were created some time ago, and also investment was needed as well. And as far as I know, there is some major work being done in this area. We need products produced by Russian developers, and there is some top-level focus on this. For example, I participated in a roundtable in Sochi where the Russian Communications Minister Nikolai Nikiforov was the chair, and he was asked these questions, and back then he voiced this idea to create the foundation for supporting Russian developers, and this found feedback with the president. So this means that we pay great attention to this issue even at the very top level, and we are moving in this direction. If we speak about our company, we're also actively working in this area. For example, we are developing basic modules, expansion modules, and specialized data automatic processing modules. Which are used by different categories of consumers. So we have basic platforms, and we also have modules. We have automatic algorithms which address special tasks for special users. Judging from your experience, are the end users and commercial users ready for shifting to Russian software? Well, let's look at this question from a different angle. They are quite ready for some special software, because this is the software that we develop for our users, and we know our users better than our Western partners. So if we do some modules for the woods sector, a similar woods industry can only exist in Canada and no other countries. So, of course, it's not the woods sector of Papua New Guinea and so on. As for the basic software, the basic toolkit that is used, here we have certain issues with investment. As I said, a certain path should be followed, but the situation is the same as with satellites. We are currently in another technological cycle. So what required years and decades earlier requires much shorter periods right now, because many things are already ready. There is the OGC, OpenGS Consortium. There is the OpenGS initiative or foundation. This is an open foundation, a foundation for open data and innovative technologies. So there are certain organizations developing particular approaches. and a lot of modules, algorithms, and platforms are being set up, which create new projects, new products, and this speeds up things. So from my point of view, Russian products, the Russian technological platform, can be even better than the Western one. And we can create an even better platform within a year or a year and a half, or 2 years is a maximum. So what about the support of the government or private investors? Can we involve them in this process? Look, the government has one main function: create conditions, not to interfere, create the rules of the game. And the government has different methods. It can issue orders or can offer some benefits, tax benefits, and so on. So the idea expressed by the communications minister involving the application or non-application of the VAT is just one of the tools. Of course, the government has a huge role to play here. The government can create these conditions for Russian developers, because Skolkovo itself is also a government initiative, isn't it? And of course, there are certain preferences, certain special conditions that the government can create. Of course, I cannot speak on behalf of the government right now. I can just offer the government to bring forward some initiatives. So, from the point of view of the business community, what's the role of the government in supporting all the trends we've mentioned? Of course, we cannot speak on behalf of the government, but we, as a business community, can shape the opinion of the government even through some development institutions. Of course, there is a lot of interaction going on at the moment between the government and the development institutions and the business community. And there are some major dialogues going on and becoming stronger over the past few years and months. And I believe that this can result in the establishment of new tools for supporting innovation. Thank you. Thank you. Mikhail, a question to you regarding trends. We are at the Open Innovations Forum at the moment, so could you fantasize a little bit? Currently, the boundaries between data suppliers and data users are being eliminated, and competition among data users and data suppliers is becoming stronger. So what's your forecast about what will happen in 5 years or in 10 years in this market? Actually, we are not trying to keep up with the trend. We are trying to anticipate the trend. So if I am to fantasize, there is one clear thing. A lot of things which are currently being created and decided by a huge number of people using some private capacities, for example, for the woods sector or for the agriculture. Well, for us it's even easier. We all have a computer in our telephone. But I believe that this is the so-called thin client. Actually, this data should be aggregated in places where it's possible to do this, where data can be processed, and we just need to use the results, the benefits of all this work. So now that we are in the virtual world, the Internet of Things and all other things like that, All of these are the new challenges which in 3 to 5 years will provide a huge synergy effect. So anticipating the trend is about understanding which technologies are going to create a synergy effect and bring us to a new level, and which technologies are not going to do this. So this is my point of view. This is how it looks like. Everything should be very simple, on the fly, and very available. So the trend is increasing the speed of processing the data and receiving the data. One thing follows another one. Of course, it's all interconnected. That's the point. You see, sometimes we have some very narrow thinking, very narrow specialization, and we cannot just broaden the horizon of our thinking beyond our specialization limits. And what you need to do is to be aware of everything here, to see the broad picture. And by seeing this broad picture, you have to follow on with some specifics. So, actually, this question correlates with what Pavel mentioned, a single information space, which can be used as a whole picture. And this picture can be used to create new services, new products, and this is what anticipating the trend is all about. My suggestion is as follows. It's an open secret that the US private business has developed because there are a number of specialized bodies there which commercialized some tasks initially set by the government. Can the Russian Rostelecom become a locomotive for the informatics market like it happened in the United States? And of course, everyone is aware that in Russia, it is difficult for private companies to participate in certain special projects and in working with the government agencies, which are very strict in selecting private companies who they are working with. So how can you become a locomotive and driver in this area? And the second question, are you considering the possibility to involve private businesses to give them an opportunity to invent new things, to say a new word in this field? Actually, that's what I mentioned in my presentation. Yes, we see ourselves as a driver for geoservice development. And this relates to our plan for infrastructure development. But we understand that we cannot do everything for everyone. Our objective is to create the basic solutions in the industry. And as part of these solutions, and as part of further customization and providing certain analytical services and so on and so forth, we see here the role of our partners. And our partners can be big companies or small companies. Our goal is to create a big market.
Some specification here, to be more concrete. Is it possible to become an informal partner of Rostelecom? Because we were getting some kind of offers for accreditation in this common space, and furthermore for offering some services like crowdsourcing of a kind. Well, so far the things we've been discussing in our pyramid were at the lower levels of this pyramid. So we're creating infrastructure, and it's probably time to think of how to work with the upper layers. But we have not reached that to a great degree of detail. So that will take place sometime next year, mid next year. There will be some pilot stories, some first partners, and as their number increases, we will move that towards a real partnership program. When we discuss satellites, we say that the main thing is getting access to the rocket, or getting your space to put your device onto the rocket. So as I see, there's always complexities in building the spacecraft, but they are not really very critical. So this is not a limiting factor. But we know the entry price is very high. So if you follow this technology chain, what do you think is the main bottleneck for this complete block of business affairs? Actually, this is a simple question, and on the other thing is a complex question. The main thing is money. The main issue is money and time. So when we talk about business, the availability of experts, well, highly trained experts. Well, Russia is rich in brains, and we have highly qualified people. But when you get to the previous issue, what could be the driver? The state could be the driver. Major corporations like Rostelecom could be the driver. So all the major companies in their industries are kind of drivers in their industry. Like Gazprom. What is their innovations budget? An approximate idea? I think there's a substantial budget for innovations with Gazprom. Or you take some other major companies like MTS. I can tell you the budget for innovations is several billion rubles, while in the US that's much higher. Take any major American company, a major like, so okay, BP is British, like that. So if Rostelecom undertakes that, and there should be no obstacles for Rostelecom, and there are no bottlenecks for Rostelecom. They have everything at their disposal. They have competencies, they have infrastructure, money, resources, just everything to implement things. This is it. So it looks like the prospects of using Russian satellites is quite okay. It's favorable. So because of that, infrastructure is being set up, which will require new actual data that allows for the processing of this data. So if you apply that to Russian satellites, we are just waiting now. Let me comment here. This is an issue, actually. This is a problem. It's not only finance that is a bottleneck or an obstacle. The things as they are now in the last 6 months, starting from springtime, the sanctions are a hindrance for satellite building or spacecraft building. It's a hindrance time-wise. The first 2 craft were launched under an American flag, and the ITAR procedure, we went through that in May, which was the hottest season. So we got our clearance for export of those into Russia. They were actually exported in Russia. They should be shipped to Russia only. And we got this clearance 24 hours before the launch. And the Canadian government refused for their device to be launched. A very sad and silly, foolish decision. There's no logic in that. So the only party that they punished a Canadian company, because 95% was already paid to Globkosmos, Russian agency, but the satellite was not launched for some political reasons. Self-inflicted damage. So we see the situation with sanctions, where more red tape, more bureaucracy for purchasing, logistics. So this is affecting timings and schedules, make it more complex, and paperwork is more complex. Okay, it will work eventually, because we do not work with the defense ministry or anybody like that. So we'll only have commercial customers, private customers. So we don't see any risks in purchasing. But we're also developing in parallel local suppliers. All suppliers from the countries that will never put any sanctions to Russia. No risk, like South Africa, China, South Korea. Thinking back, what could stimulate all of this? I would not split it, because when you say Russia, what could help Russian craft? We are not very different from the rest of the world. The remote Earth sensing, I understand. This is an international thing. But the issue is, very few Russian companies are prepared to at least follow your success, or maybe become your competitors. So what will be a driver is the initiative that Rostelecom is promoting, and that was a big breakthrough, creating a platform to develop applications that would use the data that we generate. So Mikhail could probably illustrate the efficiency of the use of data that are generated today by the satellite group. The most effective company will be selling 5% of the images that they generate. Less efficient will generate 1.5%. So a gigantic amount of data is being generated, and very few is being used. So it is exciting for everybody. Everybody's showing interest in the cloud technologies. This data is made available today, and there's vivid interest from the designers and developers, and they have started to invest their resources, mostly time resources, because all of this story has established a huge market, dozens of billions of dollars for the IT developers, and they so far have not entered the GIS, because GIS is still a certain isolated group of people. So they make some isolated ecosystems which enable us to enable people to make applications, services, because it will be understandable and available not only for the governments or bigger companies. Okay, sanctions is a hindrance, but on the other hand, this is a time for opportunities. Because if before sanctions we said, okay, we'll manage, let's buy something, let's buy Western product, then we were relaxed. Now people were a little bit, companies a little bit, cheered up, shaken. And now there's an active search for solutions. How to work in these conditions of sanctions. So countries Sergei mentioned, South Africa, exotic places. But that's an impetus for international cooperation, a serious one. So if we rely on our partners in the east, in the south, we didn't look into that much before. Sometime before we heard about, okay, Chinese, Taiwanese, Singapore technologies, some high-tech communities. But now is the time to scrutinize them. And that's quite visible today in these open innovations. And they do have a lot of things. An example, India is one of the countries that was actually at the outstart of the space industry. Well, different degrees of success, but they were at the very beginning. And they do have one of the biggest group of the GIS craft in the world. Out in this case, China, no comment at all. So this today is a time for opportunities. We have to use it correctly and to treat it seriously. Okay, to conclude my little speech, a little comment here to Michael's speech. When we just entered the project of GeoService, we were we knew we had a very hard way to travel because this new product, the new IT product, will have to compete with the existing systems already active on the market for a few years. And when you come to somebody who says, okay, but I already have my system, the RGs. So the current situation today is actually helping us because the customers today are less assured. They're not telling us, I am okay, because they'll now have doubts about the future support and development. So we view that as a possibility time, opportunity time, using this period to increase our client base and the expertise and to move ahead. There will always be competition, but things will settle down. But what we have now, we have a competitive edge. This is the case, correct. Now the expert community and the business community cooperating with the state. There's a certain movement in the legislation. There's some amendments, some bills, draft bills in the government, so that there's confidentiality should be limited, so that regardless of the source, domestic or foreign, regardless of the resolution ratings, that should be made available. And then in January there was a decree signed, or rather the basics of the state policies on the use of the results of the space activities. And that document shows support to Rostelecom. They're not mentioning Rostelecom, there's a more general approach, but there's a common technical policies, technical independence of the domestic systems, and information to be made available to the end user through the competence centers. So as I see, at this time, building spacecraft as a GIS data, processing that data and making that available to the customer, there's work being done in parallel, and there we do see the effect of synergies, which is reducing the timelines. So we would like to see actually those timelines reduced for the new services. And of course I would like to wish to all of us to cooperate more closely. We would love to attract new companies to participate, and this is not an easy job. And good luck, and we wish you all the best. Thank you.